Thanks everybody for coming to my talk. My name is John Coyne. I'm a distinguished engineer of application engineering at Discover, which is now part of Capital One. And today I'm hoping to provide some insight into building efficient testing as part of the CI/CD pipeline for container-based applications utilizing mocks. A little bit about myself. So I've been at Discover actually my entire professional career for over 20 years, mostly building and architecting job applications during that time. About the last 8 years I've been working with containers. I'm from the Chicagoland area. I live with my lovely wife and 2 young boys. And in my free time, I like to get outside, do running, biking, hiking, and enjoy some live music. So a quick look at the agenda for today. I'm going to quickly touch on some testing topics before I dive into a really cool open source project for service virtualization called Wiremock. Then I'll get into kind of putting it together in a CI/CD pipeline, and we'll get to a demo near the end. All right, so anybody that's been in software development, I'm sure, has seen some variation, or probably multiple variations of a testing pyramid. This is just a basic example, but the general premise is at the bottom of the testing pyramid, you have tests that can run very fast, you run them often, you have the most of them, and they're very quick to run. And as you move up the pyramid, tests become more difficult to run or execute, you have less of them, and you run them less often. All right, so at the bottom, you always have typically unit tests that are testing single functions, or a class, and those are running right in your IDE or on your developer machine every time you do a build, for example. As you move up, you get to something like integration testing, where you're testing how components interact with each other, whether that's another service, a database, a message queue, and there can be different interpretations of what integration testing is, and I'll kind of dive into that a little bit later. Then as you move up the stack, you have end-to-end testing, where maybe you're testing the flow from how a user sees it in an interface all the way to the back end, and you're integrating multiple systems together, perhaps. And at the top, you may have something like manual testing that's only done at the very end, maybe with things that are hard to automate. So focusing in on kind of unit and integration testing, these are maybe the 2 types of tests where maybe using mocks is acceptable, and kind of comparing the differences of some of them. So with unit testing, you're typically always only testing code that you've written, whereas integration testing, a lot of times if you're using frameworks like Spring Boot, that provides a lot of functionality out of the box that requires no code, well, this is where like running integration tests like Spring Security, for example, validating an access token happens before it probably even reaches your code, or Spring Data JPA is writing queries for you, right? So you need to have some further tests besides unit tests that are testing that type of functionality. And then as far as where they're executing, unit tests are always pretty much in your developer machine or on a CI/CD server, and they're kind of self-contained. There's no side effects or anything like that. Whereas integration testing, maybe you're deploying it out to your deployment environment and you're actually testing against the actual deployed application. Unit testing, you're always stubbing out any dependencies that you have, whereas integration testing, you want to see how those behaviors are occurring, whether that's an actual mock service or the real service. You want to make sure that if you're making a REST API call, you want that actual HTTP call to happen in an integration test. So for an example, integration test may look something like this, where your component you're building and testing is deployed out to your cloud environment. Let's say you're deploying to a cloud environment. And then you have 2 maybe services that you depend on. You're configuring those endpoints within your application, and you have a test that's maybe making an API call to your service, and then it's calling down to other services. Now this is a very simple example, and I'm sure anybody who's worked in a kind of highly distributed microservices architecture knows that a dependency graph might look something more like this, right? So trying to have automated tests set up when you depend on so many downstream services where there might be data dependencies that you don't have any control over can be very difficult to do, especially if you want that to be part of something that you execute on every commit to GitHub or with every pull request you're opening, right? So how can you have like a reliable CI/CD pipeline for certain aspects? So that's where this concept of narrow integration testing is kind of key. I don't know if Martin Fowler is the one who coined this term, but I remember he's the one I first read about this from. And kind of the idea is, right, you're focusing on the code that's interacting with those external services, and you're using test doubles of those, whether it's kind of in process or remote. And then effectively you have many narrowly scoped tests, no larger in scope than a unit test really, and you're kind of using the same framework a lot of the times that you're running a unit test with. So if it's JUnit, for example, in Java. There's a link here. I have the slides uploaded, so if you want to check out that article later, I'd recommend it if you haven't before. So now if we kind of revisit the testing pyramid, maybe we can break out integration testing into narrow integration testing and then broad integration testing. So it's not to say that you shouldn't do integration testing with real live services, but maybe when you're running your pull request builds, maybe you just want to depend on mocks instead of having it always go out to those real services. So kind of comparing and contrasting the broad and integration testing. So narrow integration tests are verifying interactions with the contract, whereas the broad integration tests are verifying the contract themselves. Of course, there's other types of testing to do this, like consumer-driven contract testing, and that's another great way to kind of verify that, but this narrow integration testing can be a great way to catch things earlier. So now if we revisit our diagram, we set up a narrow integration test. Now we maybe just have kind of a deployed mock service that has our mocks deployed there. But this introduces a little more complexity because now we have to worry about deploying a separate component for our mocks. We have to configure that endpoint within our service. So what if instead, if we're deploying, let's say, to a Kubernetes environment where we have those both in the same pod, and our mocks are just a sidecar container. So that makes a single deployment a little bit easier. Now we don't have to worry about configuring an additional endpoint. It's just a local host, so it's a little bit easier to configure. So I'll go into those details a little bit later, but first let's see how we can go ahead and build that mock service in the first place. So Wiremock, if you're not familiar with it, is an open source API mocking framework. Allows creating stubs for HTTP requests and defining responses, including status codes, headers, response body. Provides a lot of capabilities for matching on requests, templating responses, introducing latency, fault injection to kind of simulate real-world API scenarios. It's written in Java, but you can use it with other languages via the HTTP API or client libraries. We actually have a number of Node.js projects that we're using Wiremock for our integration testing purposes. So as far as running Wiremock, there's a couple different options that you have. So if you're using Java and you want to integrate it directly with your build tool, whether that's this example Gradle, you can bring in the implementation, or if you're using Spring Boot, there's a specific Spring Boot dependency. And effectively, you can just annotate a class, like a test class with like Wiremock test or enable Wiremock, and it'll kind of spin up a Wiremock server kind of in process. But as far as like kind of running that remote server, there's a couple different options where you can have a standalone jar file, and just run a java-jar. I remember we used to run Cloud Foundry many years ago. We would just do like a CF push on that jar and kind of mount our mocks through there. Now with containers, there's a Docker image that you can pull down and run, or you can extend that. And I'll kind of show how we're doing that a little bit later. Now, as far as creating the mocks that you want to use with your server, a couple different options here that I'll go through. The first one is the Java DSL. So this is more strictly if you're running it kind of in process directly with some tests. But I'm going to focus more kind of on the mapping structure when you have actual JSON files. So this is kind of just a simple example. So you first define your request, kind of how you're matching it with a URL and an HTTP method. And then you define the response, the status code, the body, headers, and then if you notice the body here is inline with the actual mapping file, but you also have the option to kind of extract that out to a separate file, so you can reference the file name and then have that the content, because especially with JSON, trying to escape quotes inside of another quoted string is a little kind of cumbersome. So whenever you create these files, if you want to serve those up to your mock server, you have to effectively have two different directories here. One of them is a files. It's a double underscore files directory. These would be the response body files. And then the mappings directory has the actual kind of request to response mappings. So you can obviously just create those files manually. You can post them to the Wiremock server admin endpoint if you want to have like a Wiremock server running and just send off a request of that kind of mapping. And it'll store that in the file system. But I think one of the best ways to actually create mocks is to record them from real API calls. So I'm going to walk through a demo of this later, but I'll kind of quickly explain it here. So let's say your application is depending on a certain endpoint, let's say GitHub API. So where you have that endpoint configured, you would update that to point to a Wiremock server, let's say you're running it locally. And then you would have to convert that Wiremock server, or turn that Wiremock server on to a recording mode, and you update the Wiremock server to say, send any requests that come in now to this real endpoint. Then you could send a request to your application, which would then send it to the Wiremock server, which sends it to the real API. The API responds back, Wiremock captures that in memory, and then sends it back to your application. And then when you stop recording, it'll essentially persist those onto the file system, and you have the request to response mapping saved that you can then use later for serving up a mock response. There's another kind of similar option called proxying and snapshotting. So this is where you have to pre-configure the API endpoint in advance, and essentially the Wiremock server can proxy requests out to the real API. So as you're sending traffic through, it's proxying it out, getting the responses, and kind of saving those in memory. And then when you want to capture the snapshot, you can send a post request to the server saying, hey, save off any API calls that you've seen, and you can give it the criteria saying, for this endpoint only, or for anything that matches this regular expression. And then it'll persist those to the file system. So 2 different ways, and I'll kind of walk through both of these a little bit later towards the end to maybe it'll make more sense. Another great option is using GenAI. I'm sure a lot of people have available this now, and this is just an example where I took kind of the famous pet store Swagger, if you're familiar with Swagger. So it's usually the demo example that they use. And I said, can you fetch this Swagger document and then generate Wiremock mappings for this given open API spec, providing a request mapping and response for each API method, and it was able to kind of generate all those files for me. So I think this is a great use case to use. Let's say you're consuming a new API that hasn't been built yet. The developers gave you the spec, and you need to start your development, and you depend on that API, but it's not available. Something like this can just spin up all the mappings for you, and you can start testing. If you're using any public APIs out there, like GitHub or Twitter or X, there's a library out there that you can download kind of pre-created mappings for you and integrate those right into your service dependencies. All right, so let me get into kind of request matching. So essentially anything that's part of the HTTP request, Wiremock allows you to kind of match a request on, and you can use any kind of permutation of all of these, and they can be exact matches, or you can use regular expressions. So kind of show a quick example. Let's say that I want to create a mapping for, I have an API that's getting account information. So it's /API/account, and I want to map on anything that starts with a 1 through 9, and then is between 4 and 6 digits after that. And then it has to be a get method, and it has to have an accept header that contains the word JSON. So this is kind of a simple example here. Now, what if I want to actually have kind of an exact account mapped, but then I maybe want to have like a fallback that says if it doesn't match this account, then just return a 404 with a custom error message. So obviously, API account 1, 2, 3, 4, 5 would match both of these, but this is where you can use a priority to kind of give a higher ranking to one versus the other. So the lower the number, the higher the priority. And in this example, the top one would be served. All right, now as far as returning responses, you can actually use a templating framework called Handlebars that allows you to kind of do a bunch of different dynamic responses. So let's say that we use my previous example of the account in the request. If I wanted to return that account identifier back in the response, I could use a method called request path, and then use like the index of that URI to kind of return that back. You can do similar things with the body and using kind of JSON path to extract out elements from the body. And then I just picked a random function called pickRandom here to kind of showcase you can have it return a random value back. And then in the response headers, I added a date. So let's say you capture a mock, and it's just going to have a date from wherever you captured it, but you can have it be the current date by using the now function, and you can give it the format that you want to have supplied back. So anytime you're using kind of these dynamic parameters, you need to supply this transformer that I've listed here at the bottom to allow it to use that functionality. All right, so not all APIs are stateless, right? Sometimes you want to have something persisted in a database or in a downstream service, and then kind of see that behavior reflected. So Wiremock has essentially like a state machine behavior where you can kind of go through. So let's use this simple example of I have an account that I want to make a payment on. So first I'm going to get the balance, and I want to see that it's kind of updated, right, after I make a payment. So here's where you use something called scenarios. So you have to give everything a scenario name, and all the mappings would need to match. And then you would have what's called a required scenario state for this mapping to be matched. So started is the default, so you always have to have at least something that starts with started. So in this example, I make a GET request to account balance. I get back $435.57. Now let's say I make a post request to this account payment with a body that contains $200. And you can see here the required scenario state is also started because I'm still at the started state. But on line 18 here, the new scenario state is partial payment made. So now if I issue that same request I made initially, but now I require the scenario state of partial payment made, I will get back a different response, the balance of 235.57. So let's say you're going through these testing, you can actually reset the scenarios back to the beginning through an API call if you have to reset that, to get back to the beginning if you want to have that for the next test suite. All right, next thing, simulating faults. So sometimes you want to be able to have negative test cases, or maybe you want to test things out like a circuit breaker. If a request fails, and does it go back to the circuit, to the fallback? So this is where you can use things like error mappings, where maybe you return back a 500 based on any sort of input you want to give it. Or I think this is more beneficial for maybe performance testing, but you can add like a fixed or random delay. So we use these a lot. We deploy a lot of mock servers for our performance tests, and then what you do is you find out like maybe the P90 of your dependent services, and you configure those as mocks, and that gives you a more realistic kind of view of how your application behaves with the real service calls. They also have like the ability to return a bad response. So let's say an HTTP connection is abruptly closed. You can kind of see how your application behaves in a scenario like that. A couple other features I wanted to briefly mention, but not really get into too much detail, is there's a JWT extension you can use to kind of generate JSON web tokens if you're using those in a mock test. They have a webhook feature where you can kind of fire off an async request somewhere when a request is matched. There's also a GraphQL extension that makes matching like GraphQL queries easier if you are using that. So check that out if you use GraphQL. All right, so a couple things to kind of watch out for. Mocks can become stale, and this is obviously where you have other types of testing to catch these things, right? This is where broad integration tests or consumer-driven contract tests hopefully catch stale mocks, and then hopefully you can kind of record new ones based on maybe a new API interface. But kind of along those same lines is if something becomes stale and you record a new mock, you may have kind of files sitting out there that could become obsolete. So Wiremock actually just added a feature recently that enables you to see mock files that are not used at all. So like, let's say you run through your full test suite, and then I don't know if it's an API call or if it's available on the UI, but you can essentially see all the mocks that were not used. So you can kind of prune those out and get rid of them. And then kind of managing a lot of mock files. Sometimes, let's say you have a service, maybe a monolithic type service that calls so many downstream services, and you have a lot of files to manage. So this is where kind of taking advantage of request matching and response templating can kind of help you reduce those down. Obviously it requires a little more development work to kind of figure that out, but then reduces the number of files that you need to maintain. All right, so now let's kind of see how we can incorporate these mocks into our testing pipeline as part of our CI/CD process. So as I mentioned before, you can directly just run the Wiremock image using the Docker run command, and then you obviously have to have the files that it uses. So you can use a config map to mount those, or maybe a persistent volume if you're running on Kubernetes or something. But what I like to do is actually build a container image at the same time that I'm building my main application image. And then I version these together, so anytime I'm deploying this specific version of my application, I know that I can use this version of the mocks alongside of it. So it's a pretty simple, there's not much here. It's, I'm just this is an example of a Docker file where I'm pulling down the Wiremock image, and then I'm defining an environment variable for the port for Wiremock to run on, because by default it runs on 8080. And if I'm going to run that in the same pod where I'm running my application on port 8080, I need to make sure I can change that in my Kubernetes deployment. So I'm setting it as an environment variable here so that I can override it later. And then basically it's just copying the stub files in and then using the Docker entry point script that's part of the base image to start it up. And you can see here I'm using the port command line parameter to kind of override that with the environment variable. And there's a link here that has all the different command line options that you can use if you want to check that out later. So once I have my image built, I'm ready to deploy to Kubernetes. So here, this is using kind of the older way of doing sidecar containers. I think if you're on the latest version of Kubernetes now, there's official support for the init container section. I think was a restart policy always. But we're still on an older version, so you kind of need to run it in this fashion. So you have your mock container image, and then here's where you set the Wiremock port to 9080, and then your main container image, this is where you just inject, let's say, your service endpoint as an environment variable, and you're using localhost 9080. And it's a simple example of kind of what the spec would look like. So now we kind of put it all together, and let's say that in a pull request, you want to do kind of this narrow integration testing. So you have a build unit test phase, then you kind of build your container images for your mock, and then your main application, deploy that out to your environment, and then run through your integration tests. So as far as running integration tests then, a framework that I like to use for REST APIs is one called Rest Assured in Java. Open source library that makes it easy to kind of test out REST APIs, providing kind of spec and validation of parameters, headers, cookies in the body. And it kind of integrates really easily with frameworks like JUnit. So if you have things that are reading kind of JUnit XML, kind of this is a great way to kind of just incorporate that into your test readers. This is a really simple example of kind of what it looks like, but basically just making an API call to a specific endpoint, and then kind of validating the status code and anything that you want to do along with the body. The DSL makes it really easy to match like JSON responses too. All right, so putting it all together kind of in your integration pipeline, you have maybe your CI/CD cluster where you're building from, and then you run your integration tests through Rest Assured, hitting your main container in your pod, and then that would communicate with your Wiremock container to kind of stub out those responses. So, all right, let me get through kind of a quick demo here now. So I have a demo application set up here. It's called Issues Handler. And it's a pretty simple application. All I'm doing is I have one API endpoint here called /issuesData, and then I'm passing in an owner and a repository from GitHub. I'm just going to make an API call to GitHub and then collect all the GitHub issues and then just count all the different GitHub issues and the labels, the number of different labels essentially that I have for those issues. So when I run my application, I'm going to be making this API call, and then when I record the mocks, it'll look something like going through Wiremock on port 9080, running locally, which will then proxy those out to the GitHub endpoint. So I'm using actually an open source library to make the GitHub API calls even easier called GitHub API. So I'm importing that, and now I'm supplying, I think by default it uses the standard API GitHub endpoint, but let's say you have the enterprise version, it allows you to override it. But just for the sake of demonstration here, I wanted to showcase, so this is where I can set that endpoint. And if you're not familiar with Spring Boot, you can override configuration properties via environment variables as well. So a little bit later, I'll be showing you how I override this for Wiremock. In my application configuration, I'm kind of injecting that property and then creating this GitHub object, which I'll be using to then make the API calls. So let me quickly start up my server here. So here you can see I have a log message, and it says, here's the GitHub client configured with this base URL. So now I'm going to load up this issues data for this Wiremock Docker repository. And here you can see it kind of just pulls down the total number of issues and then gives me the label counts. So now let me kind of run this through Wiremock. So I'm going to stop the server now. So I have a script here called start with mocks. So this is going to override that GitHub base URL to point to localhost 9080. And I'm going to be running the Wiremock server in a background process here. So let me show you real quick. I'm using a custom Gradle task I created for this. This is a really convenient way to kind of start up a Wiremock server. So I just bring in this Wiremock standalone dependency. And then I just created a Gradle task called mock server, where it's just running the java-jar, passing in the port, and then the root directory where I want my mocks to be served and stored in. And then I just run my main application. So let me do that now. So now let's check out my log file here. So now I say GitHub client created with localhost 9080. So now it's pointing to that local Wiremock server. Now if I try to refresh this, what's going to happen? It's going to say repo does not exist, because the Wiremock server it's just hitting the Wiremock server, it doesn't find anything, and it responds back with a 404. So So this is where I need to put the Wiremock recorder into a recording mode. So this is on this admin recorder endpoint here. So now I got to paste in my GitHub URL. Now I click record. And if I go back and refresh this, all right, so here's my response I'm looking for. I go back to the recorder, click stop. And you can see here it says it's captured 2 stub mappings. And there's 2 because it first makes a call to the main repo and then makes a call to the issues API. So if we go back to my workspace here, you can see the 2 APIs that it captured. This is just fetching the repo information, and then here's the issues that it got. So let me quickly stop this. So I'm going to show you how I can modify. So I'm going to change the labels of GitHub Actions. I'm going to modify those. Let's say we'll change this to OSS NA25. So now if I start this back up, and then I do a refresh here. Here we can see now it's updated those issues. Now it's pulling from my mock server. All right, so now that was kind of that one recording demo that I showed you. Now I'll show you kind of proxying and snapshotting. So my Wiremock server is not in a recording mode currently, but I'm going to load this endpoint on my repository where this GitHub repo is hosted. And here you can see it worked without me having to do any recording because I have my repository set up as a proxy, set up with a proxy base URL. So anything that matches repos with my GitHub repository will automatically proxy to the GitHub endpoint. And then what I can do is call the capture snapshots. So this is the kind of the API endpoint where you want to capture the snapshots from. And then you can essentially apply filters to tell it exactly what you want to capture, like only specific endpoints. And there's a lot of parameters here. I'm not going to walk through them all. So once I call this script here, capture snapshots. Now if I go back here, we can see now it's captured those API calls to my repository here to get that information. And now I have those available. All right. The last thing I wanted to show was just the integration test. So I also have a couple of mappings already created here for this reactor pool repository. So my integration test that I have created here is depending on those mocks. So the way that I like to set up my integration tests is to make it easy to run them locally. I kind of have like a default configured base URL. So if anytime you're doing local development, it makes it easy to not have to inject that. But then let's say when you're running these integration testing on your CI/CD server, you can just inject like an environment variable that says base URL, and that could be pointing to your real environment. So it makes it easy to kind of have a default or go to a different endpoint if those integration tests are going to be going against your cloud environment, for example. And then here I just have a couple tests, one to kind of test out the labels, and then one to do like a negative test case for a repo not found. So you can use like a custom Gradle task to make running these easier, and I have an example of that in the build.gradle, but you can also just kind of execute these right from the IDE, and then you'll see that here's where it made the API calls to actually get that from my running server, which called my mock server, to validate those tests. All right. Cool. All right, so just a couple takeaways. I hope you learned a little bit about kind of what narrow integration testing is, and how it can kind of provide fast and reliable feedback, kind of in your real deployment environment using Wiremock, which can act as a kind of a reliable test double to help you cover all different types of scenarios. I think it's really beneficial because I know, at least in our environment, it's sometimes hard to find test data that matches all these exact scenarios that you need. So it can be really beneficial to kind of create mappings for all those scenarios that you need to have test coverage for. And then lastly, using mocks as a sidecar can kind of be a great way to speed up your automated integration testing and not have to be debugging test failures for was it my code or was it some downstream dependent service that is causing my test failure. And then, in a container-based application, having that be part of kind of a sidecar makes it even easier to kind of deploy that out and have that running in your pipeline. This code's up on GitHub if you're interested to kind of check it out and play around with it yourself. Again, the slides are posted on the site too, so you don't need to really worry about taking a picture if you want, and just check that out later. But other than that, if anybody has any questions, I can take those now and have some information if you want to reach out. Thanks. Yeah, was there a question?
I was just going to ask, how do you keep help? Is there a way, like if you're a client server and there are different teams, is there a way that you recommend for the teams that are dependent on for keeping other people's Wiremocks up to date? Like, is there an automated way or like?
Yeah, so the question kind of was like, is there an automated way to keep mocks up to date, and like if you have different client server teams? So I think there's a couple different ways to use these mocks. So the focus of kind of what I was talking about is for like component tests, where like these are living in my repository, and I'm have them. They're kind of focused just for my testing purposes. Now we do have cases where like people want to use like a larger scale Wiremock server that's kind of like a shared one, where you maybe have like multiple teams contributing to it, and then so that's a better way to do it. Like the team owners can kind of keep those up to date, and then those are kind of like, and then those can be like cloned down too. So let's say you want to have the teams who actually own the services publish those mocks. Other teams can maybe copy or kind of clone those repositories down and kind of use those from there. Yep. Yeah.
I think you kind of already answered this, some of your slides, but say I have an instance where I have a post or a GET request to the mock server, but I wanted to act differently each time to expose the error handling from my service.
Mm-hmm.
How did you do that again for having those multiple requests where I'm still making the same request?
Yeah.
Or to get back different?
So you could, that's where the state machine comes in. So effectively, you could just have, every time you make the call, you can have it go to a new scenario state. So you would effectively have to define multiple scenario states. So you could say like started, get ABC is scenario state started, but new scenario state is step, phase, step 2. And then you have another one that says, required scenario state step 2, exact same, API endpoint, and then you can just keep defining as many as you want. So, yep. So yeah, that's like a perfect example to do for like circuit breakers, for example, right? If you want to test, okay, I want my first call to fail, but I want the second one to succeed, and then get the good response. So, yep. Anything else? All right. Well, thanks everybody. I'll be available at we have a Discover actually has a booth, and I'll be actually heading there shortly after this. So if you ever want to talk about anything else one-on-one, let me know, or show up there. Thanks a lot.